Thank you, everybody. I'm going to talk about profiles and platforms, which are one of the ways that we're advancing the RISC-V ecosystem. And I'm probably going to offend a bunch of people with my next slide because I've almost certainly left out a bunch of logos that should be on it. But if we look at where we've got to with our open ISA, we have a vast collection of people making IP, and we have a vast collection of people making SoCs, some using their own internally developed IP, some using IP from the IP vendors. And this is great. This is exactly what RISC-V was all about. Openness and building a broader community. So we should be very happy where we are. There's just one slight issue. It can be very, very scary to software people. So if we look at what we've got in RISC-V, we've got our core ISA, which is on the left here, and we've added to that a bunch of extensions to the ISA, a bunch of non-ISA extensions, and a bunch of software specifications that we've used, and then people are free to push in their own custom extensions. So this is great. This enables the diversity and flexibility that we've been hearing about this morning. But if you're a software person and you see all this flexibility, you'll say, well, what can I rely on being there? How can I write my code if I don't know whether these extensions are going to be supported or not? And the answer to that is what we call profiles. And this is essentially to give certainty to the software developers. That's the whole point of a profile. Give the software developers certainty. And there are various profiles. The particular one I'm going to focus on today is the application processor profile, so RBA. There's also an embedded RBB and a microcontroller that's still under discussion. So RBA gives a set of mandatory use of extensions. And so if you are writing code, if you're writing user-level code or hypervisor code for an application processor, and it says it follows the RBA23 profile, you know exactly what extensions you can rely on being there. There's a second thing, which I'll talk about a little later, called platforms. And this is about providing certainty to the operating system and firmware writers. And I'll talk in a little bit about how that comes in. So the profile, and there can be many, but RBA23 is really about applications, and it's broadly applicable across mobile laptops, servers. And if you are writing software and you want to distribute it in an app store, or you want to distribute it as part of a distribution, most likely it's going to be a binary, right? You're not going to distribute something that the end user has to compile. So you have to know what instructions, what directives to give to your compiler. And RBA23 for the 64-bit application processors says exactly what's there. And the goal here is if you move from one vendor's RBA23 profile processor to any other vendor, your code will continue to run correctly. Doesn't talk about the performance level. Obviously, if you've got a high-performance chip or a low-performance chip, you'll see performance differ. But your code will run, and that's what the profile is there to ensure. The platform level is when you delve one level deeper. So if I'm writing an operating system or doing a Linux OS distribution, again, I want to be able to install that whatever vendor of RISC-V SoC I've got. And so the platform level specification is saying what things must be there that the operating system can rely on. So if we look at this in a server case, since I'm Rivos, and we're doing servers. I'm particularly keen on the server case. If you look at the application layer, as I said, you want to be able to distribute binaries. But if we look further down the stack, we need to know. And if you look at what happened in the ARM server space, and let's learn from our competitors here, in the ARM server space, it was kind of a mess to start with. All the vendors were doing things in different ways. No one had any certainty, and so it was very slow for the whole space to take off. And at the European Summit last week, the service provider Scaleway, who actually have RISC-V available as a cloud service, they indicated that for their first RISC-V, before we talked about doing platform specs, they had exactly the same problem. They went through the list of problems with not supporting what was expected for a server, not supporting the right firmware interfaces, not supporting the right management interfaces. So for the server spec, it's very important that we all coalesce around the same set of features that are needed by the people installing servers. Okay, I'm not going to read through all of the list of new things that are in RBA 23, but it's important to understand their categories. So mandatory is exactly what it says. These extensions must be supported by everyone who does the RBA 23 profile. There are a couple of what are called localized extensions. Primarily, these are cryptography, so they're sort of fairly complex and potentially large extensions. And if you're selling to a particular region, you may only want to support the cryptographic protocols for that region. So this is why these are localized. You can, if you want a worldwide part, you'll obviously want to put all the algorithms in. If you're regional, you can save some complexity and potentially area by selecting only to put particular ones in, and then the others will fall back to a software library. Development extensions. This is the RISC-V standard indicating that these are things thought to be good. They weren't quite ready in time for this level of the profile, but they're expected to be mandatory next time. So if you're making a part, it's a good idea to put these in because they're going to become mandatory. So if you've got them in, then you won't have to scramble to put them in for the next profile. And then there are optional ones, which sort of sounds contradictory because we were saying it's supposed to give certainty to the software. These are mostly done in fairly clever ways so that you can either detect whether they're there or not very easily in a library, or, for example, the control flow integrity ones, the landing pads and shadow stacks, they're coded in such a way that if a processor does not support them, they'll become no-op instructions, or something that's in the mandatory set called a maybe-op instruction, which just loads 0 into a register. So those can be safely used by software, even though they're optional. On a processor that supports control flow integrity, they'll strengthen the checks on jumping to subroutines and returning from subroutines, and make sure you're not getting suffering from any stack overflow attacks or anything of that nature. But on a processor that doesn't support them as an optional extension, there'll just be no ops, and they'll pass through without any concern. So there is some care done with the optional set of instructions. The server specification then builds on RBA 23. You'll see that specifies the applications and the interface into the operating system hypervisor. But below that, there's a whole bunch of other stuff that goes into a server. There's how you talk to the management control. That's how you talk to the I/O system. And so the server platform spec is built on the server SoC spec, on the software boot and runtime services. That tells you how your boot software passes information up to the operating system. It's built on the security model that the RISC-V security teams put out, and generally pulls together a bunch of industry standards and says this is how RISC-V is going to support these. In particular, as I said, the Scaleway guys were really pushing the UAFI and ACPI as the mechanism for the booting and passing information from the boot code to the operating system. The service SoC specification talks about what, there's a timer defined in the standard spec, but it doesn't define what frequency it counts at. So that's tightened up in the server spec so that if your operating system is expecting a clock, it will always know what speed it's going at. Similarly, in the PCIe subsystem, PCIe is great because you can discover what's out there. The question is, how do you know where in memory you look to start discovering things? So there's a bunch of specification that says how you pass to the operating system where to look for the PCI configuration space and so on. So this achieved its goal, and Rivos and Canonical recently announced that we were bringing Ubuntu for data centers to RISC-V, and it's not just enabled for Rivos, it's enabled for anyone who uses the RVA23 profile and the server platform specification. What this means is that Canonical can do one Ubuntu distribution and it will install across all vendors' machines, which is exactly how things work in the traditional x86 ecosystem. And there's a nice video of our software lead and the Canonical lead discussing that if you're looking on our YouTube channel, I would recommend the 6-minute version because it's much more complete. How's Rivos building this? Well, we're taking those two specifications. We're using them to build our CPU implementation and our SoC, and therefore we're going to be ready to work in a RISC-V server along with our AI accelerator, because everyone does AI these days, and put the whole system together. But as I said, Canonical can support us because we use the server spec and the RVA23 profile. Finally, visit us at our booth. We've got a booth downstairs in the RISC-V area, and you can visit us again at the A-Speed booth, where we have we used their BMC chip and built a Open Compute compliant DCSCM card. So stop by and see that as well. Thank you.